All right, I'm going to go through some of these answers from the BC Quickfire review yesterday. So I'll go quickly, but hopefully you can follow along. The first one was an integral of a product, and the review piece was to review integration by parts. So I did rapid integration by parts on the left here. So you can kind of review that, take the derivative of the one column and the antiderivative of the other. And then when I connect them, I'm going to have a negative 1/2 x squared cosine 2x. That's this first combination. And then I have a double minus here, so that's going to become a plus. And then I have a 2 over 4x sine 2x. And it looks like I'm going to have a plus 2 over 8 cosine 2x. And then always remember your plus c. I think that's going to be the answer. Remember that last term, if you are figuring out where to stop, you'd have the integral of that last horizontal thing. But it's 0 times who cares, and the integral of 0 would be c. So nice little piece there. All right, second one, you have an improper integral. That means we're going to infinity. So the first step is to rewrite it as a proper integral. So kind of replace the infinity with a b and then slap a limit on it. And so that's the setup for it. But then the integral itself is an integration by parts. Remember, if you had this integral, e to the x squared, this would be a u sub, where u would be this, and then du would take care of the product. But can't do that for this particular problem. So I got the integral worked out here. Whoop. So I can rewrite this as the limit as b approaches infinity. And then the integral is going to be negative x e to the negative x minus e to the negative x, and then from b to 1. So that's going to be my setup. And the next step, the limit's going to be the last step. The next step is going to be FTC. And so when I plug in b for x, I am going to take advantage of the power rule, or power property, where I can rewrite these as 1 overs. And then FTC, I'm going to have minus, and then we got 1 over e to the 1 minus 1 over e to the 1. So kind of a big mess. So now I've got the limit as b approaches infinity. And I'm really only going to be applying the limit to the things that have b's. And so, in fact, if I do that as this step right here, so I'm applying the limit. So I'm really going to have infinity over infinity here, but if you remember the magnitude piece, the infinity with an exponent has a higher magnitude. So this is going to go to 0. 1 over infinity, that's going to be 0. And then these are actually just constants because there's no b's in them. So it's a minus, and then I have a minus 2 over e. So I believe when all is said and done, it's going to be 2 over e, which is kind of wild. And if you wanted to tie it in with recent stuff, you could say that it converges. All right, this is an FRQ from 2019 AB test. If you want to reference it, I think it was number 5, but I'm not 100% sure on that. The first part asks you to find the area of R. I'm not going to find the actual values just for the sake of time, but you could punch them into your calculator. I think they're just going to ask you to set stuff up on this year's exam. So anyway, I see a top minus bottom idea here. And so we're going to have a dx happening, which means these need to be x values. And sometimes we find those with intersection points. Sometimes they're given on a certain interval. And then the idea is you have the top function minus the bottom function. And if those are labeled, and they are on the FRQ, or if you're looking at the PowerPoint, this was a function. And if you have that labeled, you can just put the label for it in the integral. That would be it. Part B asks for a cross section, And the ones we did in class were usually like squares or circles or I don't know what else you did, semicircles, I guess, triangles. The general formula is to find the area of the cross section. And in here you'd plug in like your square formula or whatever you're working with. But I think what threw people off with this one is it tells you in the question that the area of the cross section, I think, was 1 over x plus 3. So it tells us that. And it also says that the cross sections are perpendicular to the x-axis. And that's telling us that we want to use dx. And so I believe that you're just going to have this as kind of your big structure, but it actually gave you a of x. And so it's not that hard of a setup, and then maybe the second half of the question, because I think this was a non-calculator question last year. You know, you'd have to use ln and kind of go from there, and it tests you on something else. But right now I'm just concerned about the setups. All right, and then the third part is the trickiest. It asks us to rotate around the line y equals 6. And anytime you see that word rotate, you want to be thinking pi r squared. That was where that pi came in. And so if you think about having a line up here at y equals 6, the idea is we're going to rotate this around this line. And so we have two functions, so you're going to have 2 pi r squareds. So if I was to break this down, first it's going to be dx, because it's like you're rotating around the x-axis, but the x-axis has been shifted up 6, and so 6 is going to be in our answer. So we're still going to go from 0 to 2. But you want to think of this as pi r squared minus pi r squared. You want to think of it as kind of like the big radius minus the little radius. And if I start with the big radius, the luxury of color here, the big radius is, so here's my big circle, goes way up off the screen. But the radius is this distance. And that distance is 6 minus this little chunk down here. But that little chunk is g of x. It's kind of deceiving, but that big radius is 6 minus g of x. If it's hard to see, I'll try to show you the little radius real quick. The little radius would be from here to here. I wanted to switch colors. Brown. And again, from here to the bottom is 6, but from here to the bottom is h of x. So this distance right here would be 6 minus h of x. And so that 6 kind of works itself in there. And so that question actually last year just asked for the setup, and you can see it's kind of complicated. So I would study that. That might show up this year. All right, Euler's method, another fun topic. Euler's method is a differential equation approximation, and it says approximate the value for f of 1, and that means what's happening when x is 1. And then it says using Euler's method twice. Sometimes it says using 2 iterations. So that's giving us a hint on what we're going to use for dx. Using 2 steps, 2 iterations. So dx is going to be 0.5. And we kind of need dx because the idea here is if you isolate dy, remember dy you can think of as the change in y, we can essentially, to find our first dy or dy1, we're going to take y, our first y, and our first x. We're going to take dx, and it looks like we get 3 times a half. So we get 3 halves. And you take that 3 halves and add it to your old y. So the first y we started with was 3. And if we add 3 halves, you would get 4.5. I'm just using decimals, so I don't have a calculator in front of me. And so over here, I don't know why I wrote it down here. Maybe I could have wrote that up here. 3 times 0.5 equals 3 halves. And then you're adding that to your old y. Now, if I do this again, I'm going to take my new y minus 3 times my x times by dx and get a new dy, dy2, so to speak. And it looks like just coincidentally, I'm going to get 3 halves again. And if I add that to 4.5, it looks like I'm going to get 6. So the final answer, if you use a table, awesome, but make sure at the end you say something like, your final approximation is 6. So that's Euler's method. Good stuff. Keep checking the time because I think YouTube only allows me to do a 15-minute video, so kind of a hassle. Okay, so the next one asks for what sum does this converge to? And I intentionally put a geometric series, but the mistake I made was that the r here is 3 halves. And remember, for it to have a sum, the r needs to be between -1 and 1. That is where it converges, and it has a sum that you could find using this. Make a note card for that. But this r falls outside of this boundary, and so that's my bad. Whoopsies. So this actually does not converge. So it has no sum. So if I give you another quick example, let's give you one that does converge. Let's say that you had this series. So looking at the pattern, r is equal to 2/3. And if r is between, -1 and 1, it'll converge. And that sum would be the first term, 1 minus your r, which would be 1 over 1/3, which would be 3. So just a little example on the fly. All right, I'm going to stop there real quick. I'm going to post 2 videos, but this will be the first one, and we'll start on this one and the second one. So thanks for watching so far.